Okay, hello. As already said, I'm Petr Smrček. I came from Warhorse Studios from Czech Republic, and today I will tell you something about maybe the slightly crazy amount of people we are trying to simulate in our games. This talk will actually be at least a little bit about both of the games, because some of the techniques we are using in the Kingdom Come Deliverance 2 were developed already for the first game. If you somehow made it to this talk and you don't know what these games are, don't worry, I will get you covered. Those are open world RPGs, and they are maybe a little bit unusual by having no fantasy elements in them. They are trying to be as historically accurate as the central medieval Bohemia was. Also, an interesting property is it's kind of a medieval sandbox, like a medieval GTA. There's a big main story, but you can also roam the world and mess with the NPCs the way you want. They are both running on CryEngine, although we heavily modified it. And it took us some time. We actually worked for like 7 years on each of the games. So the original KCD came in 2018, and the second one just earlier this year. First, just to see the scope of our game, we have 2 maps that are approximately 16 square kilometers. And on the one that has more people, there is 2,400 NPCs. And 1,500 of that is concentrated into a single big city. And those NPCs aren't just standing there, they are all simulated, they have complex behaviors. And if you would be making this game like several years earlier, or decades, you would probably try to despawn the NPCs that are far away and simulate just the ones that are close to you. But that's not what we do. We're actually trying to make the game as immersive as possible, so we are simulating all of them all the time. And that has a really high cost, and that's what I am going to try to show you how we tackle that. So, the content of this talk will be, first, the reasons why we are actually doing this, the reasons why we are simulating the whole world. Then I will want to show you maybe a naive solutions we did for the first game when we weren't as experienced. Then I will go to the more mature solution for the Kingdom Come Deliverance 2 that we are using right now. There are also special cases for the city, which has a very high density of population. And finally, when we already had this tech to simulate a lot of people, we could use it to some other parts of the games as well. So, the immersion, first part. We are trying to achieve with these games an illusion of player being really there in person, living his medieval life. And what are we using for that? First is the realism. The games are trying to be as realistic as possible. So the people there are actually wearing the correct clothes they should have been wearing during that time. They are doing the correct things, using the correct items. Even most of the vegetable is the same. And you as a player have chores. You have to sleep, you have to eat, you have to basically plan your day as we all do when we get up in the morning. We also have quite deep systems. So for example, the NPCs are carrying items or clothes. They are putting them in the chest before they go to bed. You can loot it. Then they don't have it. They have to deal with that. They will be probably naked or spare clothes. And the behaviors are also very complicated. Those NPCs have basically their lives. They have a house they live, a bed they sleep in. They get up in the morning, have a breakfast, then they go to work. In the evening, they might want to go to pub to have some fun. And you can interact with all of that, doing small crimes, and they are very, I would say, nitpicky. You can even stand in front of the door of some NPC for too long, and he'll get suspicious of you and ask, what do you want? So we are simulating the whole world. And what are the main advantages of doing that? First, the NPCs are actually correctly positioned at all times. Because we have those complicated behaviors, the NPCs might not be at the same position during the whole day. So they might be living somewhere, and they might go to work to a field, which is quite far away. So you can follow them, and they will do all the correct things. You can even be at the field, and they will arrive at the correct time and interact with you maybe. Also, there are consequences that affect the world. If you, for example, do some crime, run away, you won't get away with that. The guards will simulate everything if you was there. And if you, for example, kill an innkeeper, the NPCs won't be going to that pub. It won't be open, so they will do some different behaviors, even if you are far away. And the player is actually not necessary for this world to work. And the big advantage is that it can be also scripted this way. So the scripting logic, the quest logic, can count on everything being there at all time, doing all the triggers at correct times, and sending all the NPCs where it's necessary. Of course, it sounds really good, but it's really heavy with performance, and that's why we are doing some level of detail of the AI simulation. So, the first game, and some of the things we did for the first game. At the very beginning, where we started to develop Kingdom Come Deliverance, we had the idea that the world should be deeply simulated, right? Everything should be as in real life and not as in the games. And every good developer knows the first rule of optimization. First make all the features, then profile, then optimize. So we did that, right? We created one big level without any loading screens, because we didn't want loading screens. We created all the behaviors, all the NPCs, and then we tried to turn on the console, and it immediately crashed on memory, right? So when we fixed it a little bit, so it could run at least, not crash immediately, it ran 2 FPS. So we had to do something. And the big issue was that we already had a lot of system done, so we had to do something on the fly. We couldn't remake all of that. Before I show you what we did to solve that, I have to at least briefly introduce you to the core of our technology, the modular behavior trees. We have actually a custom implementation of modular behavior trees. What it is, it's basically a visual scripting language. And our version is very low level. So normally you have those nodes that you connect together. They are like line of instructions. Some of the nodes do something. Some of the nodes are just for branching. And we have even like loops, conditions, expressions. We even have a switch statement there. So it's basically Turing complete twice over. And we run those trees to simulate almost everything. We do the behavior selection using the trees. We execute the behaviors using these trees. And we execute the reactions as well. So this is an example of a little part of a behavior. A woman is pulling a bucket of water. She has an empty bucket down there, and when she pours the water, the bucket will now look filled, right? So this might be like a really simplified behavior tree for that. We are basically playing an animation. Somewhere in the middle of that animation, there's an event that will be triggered. We catch that event, and we react by setting the property of the bucket, so it changes model and it looks filled. Okay, so now you see at least a little bit of the basics of our script, and let's return to the place we were. We had all those trees, and the game didn't run. So we tried to strip away things that were not necessary, right? When you have faraway NPCs, you don't have to simulate a lot of things. They are definitely not visible, you don't have to render them. If you are not rendering them, they don't have to be animated. And if player doesn't interact with them, there doesn't have to be physics. But it turns out, if you strip the animations, it breaks the script, because we are not running the animations, we are not getting those events, and the logic is not correctly simulated. It might seem that it's not as necessary to have a bucket filled with water for the world to work, but we had a way more complicated logic there. This was just a simple example. So what we did to tackle that, we introduced the LOD branching in the script. We basically created another branch in the tree that handles the simplified simulation. So it looked somehow like this. You see, this is the exact same tree, but we added the part in the yellow rectangle, which has some LOD guardian node that is basically just branching based on which level of detail you are at. And the simplified version in the yellow rectangle is basically just waiting and then doing the only consequence, which is the very same node that is in the full simulation, just changing the bucket to look filled. This looks nice, but it turned out to be actually really complicated, because this is really a simple tree. Our trees were more complicated. There could be many animations in a line, and you must be able to switch at any time in the correct consistent state. So there was often a lot of nodes, a lot of logic handling just this transition to the other branch. Another thing we did is movement. It turns out if you turn off physics and animation, the NPC can't move, right?
So what we did was we were teleporting them, but we wanted NPCs to be at correct times at correct places, so we couldn't just teleport them to the end of the road. So what we did, we ran the normal pathfind, and then along the pathfind we executed those small consequent teleports. The big advantage of this approach, or at least how we implemented it, was that we made it completely transparent to the script. So in the behavior tree, we have just one node, which is called move. And it doesn't matter in which branch you run it, whether the optimized or unoptimized, you don't have to be in any branch at all. The logic of the switching of the LOD is hidden within the node. So when you run the node, it just looks what the current LOD is and runs the correct simulation. And it reuses the pathfind when you switch the branch. Okay, so we did some of these things, and we optimized the faraway NPCs, and the game actually did run way better. But that was mainly the engine stuff we stripped. We also made some script branching, so our trees got smaller, right? So that should be faster. That would be nice, but no, because this is actually our behavior tree for sitting at a bench in a pub. And only this small part down here is the behavior execution, and only small parts of that were branched by the LOD branching. If you are wondering what most of this does, it selects the behavior, then it selects the correct place you should sit at. There are more chairs at the bench. It handles like long distance movements or some quest injections and stuff like that. So we actually, by the LOD branching, we stripped only a very small part of this execution. So it was still running for with a lot of performance hit. It turns out if you are running some script, some AI logic, it will be interacting with a lot of systems. It will be touching movement, animations, everything. So it has to run on the main thread. But our AI update was above 10 milliseconds, sometimes even spiking to way more. So if we kept it on the main thread, we wouldn't have many hopes for at least reasonable frame times, right? So we had to do something bold. We moved it to a thread completely. This is our brief overview of the threads. The top two threads are main thread and render thread, and the other workers, they are basically running asynchronous jobs. And this is what we did. We took the AI from the main thread and we put it kind of neatly at the second half of the frame. The reason for that is that the physics and animations at the first half of the frame are updating all the entities, all the positions, all the states are updated here, and then these informations are locked down, and the render on the main thread will try to prepare the next frame, the rendering for the next frame. So the entities can't be touched anymore, which has the advantage that our AI update is not racing with any other systems. But there is a disadvantage that the AI cannot change anything, right? So what we do is we actually do all the simulation, and we defer the results to the end of the frame. So they are executed right when the render ends. This saved a lot of time. It might sound simple, but it was extreme amount of work, but it worked in the end. So the results for the first game. This was all about the first game. We actually managed to simulate 600 NPCs at all times, but the frame times weren't that good. I'm actually talking about the performance on consoles of the time, Xbox One and PS4. The visibility was 60 meters or 90 if you account for hysteresis. But we actually haven't managed to simulate all of the NPCs. Some of the less important NPCs in the villages were unloaded when you got far away. Also, our script logic was very bloated. I showed you like the huge tree, and that had the branches which had to be handled. So that caused a lot of bugs. And also, we were still simulating a lot of logic in the scripting trees. So our faders or even NPC reactions were very long. So, but the game came out and it was kind of success. So we knew we could do better, right? We knew where our like weak spots were and what we could improve. For the second game, we got bold. We wanted way more NPCs and a big city. And we also wanted to fix the issues we had with the first game. So we didn't want the branching there in the script, causing all the bugs. And we actually wanted the scripters to be able to strip the game, not like the low-level systems, right? And we wanted all the NPCs to be there at all times, like the original vision was. But we had a big advantage at this point. We were starting the development, and we could design the game from the very beginning with the AI LOD in mind. So, without further suspense, let's see the core of our current solution. We actually now have 3 main LODs. The close one is basically the full simulation. We do it only for 70 closest visible NPCs, and only when they are at least 150 meters far away. This is basically the same picture, just zoomed slightly out. The blue dot is player, and you can see that some of the NPCs that are a little bit further on the outskirts of the village are already in the middle LOD, our second LOD. And the main assignment for these NPCs is that they have to be able to quickly switch into the close LOD. And we can support up to 400 NPCs that are no longer than 600 meters, because then it doesn't make sense to simulate more of them. Maybe you can see that together these two numbers, 70 and 400, are quite similar to the first game. But we added a third LOD, which is for the NPCs that are basically at another villages, and that enables us to heavily optimize those. So this is the same pictures, again zoomed out, with the player being the blue dot, and you can see the other villages in the country. So, the middle LOD, as I said, the main point of this LOD is to strip some things, but being still able to quickly switch into the correct simulation state. So we actually have to simulate the whole AI. We need the position and the state to be precise. If we are playing several animations or a long animation, we still have to know exactly where we are. We did similar optimizations to the first game. So we stripped the physics, animations, rendering. We found some small other updates that could be skipped. When you looked closer to the CryEngine, for example, the updates of water splashes and small things like that, but mostly the same. But we did one huge change, and that is that we made the animation simulation transparent. So we did our own animation simulator that doesn't care about the bones. It just runs timers and triggers the correct events at correct times. We also made the execution part of the behavior trees a little bit low level, but that's actually a topic for another talk, which is hopefully or luckily already existing. If you have access to GDC Vault, my colleague Maciej Marko actually had a great talk about the goal-oriented action planning and the changes we did with the modular behavior trees to improve this. So the middle lot was very similar to the first game, but now the new technology, the far LOD. So the far LOD is actually already quite far away, so the player has to travel to reach those NPCs. That enables us to be way less precise. It's enough with the position being up to 10 meters, and we don't actually have to simulate the correct state or item handling, because there's enough time to start it up when the player gets close. So we actually don't execute the behaviors. We just run the behavior selection part of the algorithm. And here you can see a pub. The pub in our games are mostly outside, like they were. And those red dots are the NPCs in far LOD, and they are not correctly sitting at places at the tables. They are just in the pub, because that's enough. When the player approaches this village, they will start their behaviors and get to the correct place. We also have a fast behavior startup. That means that, for example, the items or clothes of the NPCs will get synchronized right away, instantly, because if you were approaching the village and some of the NPCs switched to the closer lot, and they would realize, oh, but I need this item in my hand, they might be forced to leave the pub, go to pick the item, and go back, and that we don't want there, right? So This is actually one of the biggest changes we did for the second game, the selection of the behavior. We looked at the huge trees of the original game, and we saw some repeating patterns, actually. All this big tree was mostly handling the behavior selection, and that was time of the day when the behavior should be played, or some weather. Also the properties of the NPC, whether it's drunk, needs to sleep, or whether maybe social status, or whether the gender. There are also constraints. So if there is the woman pulling water from a well, no other NPC can be there at the time. And also there was some random systems. If you select some behavior by chance, then you are locked into the behavior for a while. So when we saw those repeating patterns, we actually realized we could get rid of the tree and simulate everything in the code, and just made those patterns be parameters of code execution. So this huge tree got removed, and that helped not only with the far LOD, but for all the simulation of everything. So it is configurable in script, but it's executed in code. So what actually do we do for the NPCs in the far LOD? The whole execution is now in code. Because we have the behavioral selection in code, we can run it to find the behavior. Then if the behavior is different than the one run up to this point, we do need to do the switch. And the switch will change some constraints. For example, there's the innkeeper in the pub. If innkeeper comes to the pub, he opens the pub, and other behaviors will get open for the visitors. So when we do have those global consequences settled, then we have to decide the position where the behavior is happening, and we do this automatically as well, because it's enough to be 10 meters within the correct distance, so we can just pick any position of any animation that will be participating there and just teleport the NPC there. And if the NPC is too far away, we will move it. And we actually simplify that as well, because we have this big graph of paths that's actually following the real roads, and we don't run the full pathfind, we run pathfind only along those roads. So the NPCs in the far LOD move only along the roads, and most of the time that's enough to get them close enough and finally teleport them to the correct destination. So by having those simulations being so simple, we could actually strip way more things in the far LOD. So we could actually save some memory. So what could we release? The biggest saves was in character, which is basically a skeleton and a mesh. We could completely delete that from a memory. We could delete the physical representation. We don't have just capsules. We have articulated physics. Then we could remove most of the behavior trees that weren't being run, and some other AI components like combat or some perception stuff, and basically some other engine stuff that were big enough to pay off to be removed. What we kept is some RPG representation. Well, this is the state we want to keep, the health and stuff. We had to keep some part of the AI to be able to react to things. And then basically we kept systems that were small enough that it wasn't worth removing them. Doing this, we lowered the memory for each NPC under 50 kilobytes, which is 25% of the original size, approximately. So I just said that we removed most of the behavior trees, but we kept some systems for the reactions. So what do the far LOD NPCs do when they need to react to something? They don't have any perception, because there's rarely something to perceive. Even if player does something and runs away, only a very small amount of the NPCs in the world have to react to that. So it would be a waste of resources if we simulated that for all of the NPCs all the time. So what we actually do is that we have a representation for the crime itself. It's this thing we call perceptible volume. So if you, for example, kill some guards and the system, you would run away and they would switch to the far LOD, there will be those perceptible volumes that are representing the crime you did. And those perceptible volumes are actually actively searching for NPCs around them and forcing them to be switched into the middle LOD. So the NPCs then, when they switch to the middle LOD, can simulate the crime fully. So even if you kill someone and hide the body and run far away, it actually matters how well you hit the body because all the crime resolution will get simulated. If you want to know more about perception or crime, I can recommend a talk of my colleague tomorrow, Design for Everything in KCD2 by Vadim Petrov. Okay, so the general thing to take away from this is that if you can make something passive in the far LOD, do it like this passively. Okay, next part is the city of Gutenberg, which was the ultimate bottleneck for everything we were doing in the game. So the challenge was to make the city look busy. We actually didn't know how many people are necessary for that or how many people we can support, but spoiler alert, it turned out to be 1,500 NPCs. And we definitely couldn't increase the budget of the 70 closest NPCs. Because we were actually happy that we didn't have to lower the budget because the city was such a performance-heavy thing. But, as I already said, we could start designing the systems from the very get-go. It was a huge help because we could make a white box of the city and we filled it with dummy NPCs so we could see how many NPCs are actually visible, how lively it would probably look like. And the city was designed in a way so that not too many NPCs were necessary to be visible at the same time. So what we did? We didn't do any long streets that would be busy with too many NPCs. If you actually pay attention, you can see that we don't have any see-through fences in the city. They are all opaque walls. If the player is walking the city walls, which is something we wanted him to be able to do, he can't see into some busy squares, and he could see a lot of space under the walls, but those are the places where we put way less NPCs. We also added some soft vision breakers like carts of hay or some stalls with shopping. And of course, there are speed limits. You can't dash with the horse in the city. And that is not only because of the NPCs, but also because all the graphic, all the streaming. So we already had the city with this structure, but we still had to somehow leverage it to some algorithm that would use this structure. So what we came up were visibility areas. So we split the city into areas that were approximately 100 square meters, and we defined their relative visibility. So here you can see the player is in the yellow area, and he can see into all of the green areas. We couldn't use occlusion that's used in rendering because we needed to know a little bit in advance which NPCs will be visible because the switch is still not instantaneous. It needs at least like 1 to 2 seconds, so occlusion wouldn't be sufficient. Also know that these areas are used only for the switch between close and middle LOD because the far LOD is so far away that the structure doesn't no longer has the same meaning. So we can see as the player moves, the areas that are containing visible NPCs actually change. And here you can see the border of the area, and when the NPCs move, they naturally switch into the correct level of detail. This is the bird view of the city. The player is in the middle, and you can see the green cross there probably because he's currently staying at the crossroads, so he can see into 2 streets, but many of the NPCs that are actually close can be switched to middle LOD because they can't be accessed quickly. You can also see that the far LOD is way closer than normally, and that's why we have the speed limit there, and also the behaviors of the people in the city are carefully selected so they can start very quickly. And when we had those visibility areas, we actually use them at other locations. So on the left, that's the Sigismund army camp, and on the right, that's the Trotsky castle. There's way more areas than in the city, but they help still. Okay, so results for the city. We actually managed to have 1,500 NPCs and still run 60 FPS. That's because we just kept the budgets for the rest of the game. We just more appropriately selected which NPCs are in which LOD. The vision distances are actually quite low. They can be as low as 50 meters, but that's where we add some soft vision breakers, and we also don't pop the NPCs into existence right away. We defer them. So if they are, for example, at the 50 meters and there is some visual obstruction, like the stalls, it's not really noticeable. There is a funny thing that when we actually found out we can run those 1500 NPCs, we hit the bottleneck of the environment settling, because all our NPCs have to live somewhere. They have to need a house with bed, and we didn't have as many furnished houses. And the environment team was already strained and couldn't make more of them. So we actually had it cheated a little bit. The NPCs, some of them are actually living in the inaccessible houses. They get close to the door. If the player doesn't look, they teleport inside. They pretend they are sleeping, and in the morning, when the player is not close, they teleport outside and continue their day normally. Okay, so we had this technology. We could simulate faraway NPCs cheaply, and we apply it to more things than just the regular simulation. Our skip time is actually simulated. We don't just switch the time to correct time of day. We actually run the whole simulation. So if you, for example, do some crime or are in danger and you try to skip time, you will be woken up, interrupted, and everything will have to be resolved. Also, the quests will progress as they should if they have some time limit or some triggers. So what we do, we actually can switch way more NPCs to the more optimized LODs. You don't see any of them, so there are no enclosed LODs, and only a few of them are in the middle LODs, only those very close to the player. Very similar thing actually happens during the fast travel. We actually run the player through the road, and he can meet people. So if there will be, for example, encounter, you would be traveling the world, you meet some bandits, they are too strong for you, so you run away back, and then you try to fast travel over them. You cannot, you will be interrupted again by the very same bandits. The battles are something slightly different. Player actually cannot leave the battle area, at least not without the game over. So we can switch almost all of the world to the far LOD, and it is still simulated. So if you do something just before a battle, you have to deal with it after a battle. For the soldiers in the battle themselves, they are actually optimized very differently because the use case is very different. They don't have any behaviors they would have to choose. They are just standing there waiting for their turn, and they are always visible. So what we do, we don't use LODs for them. We actually simplified them in a different way. We have sprites for the very far away NPCs that can't be reached anyhow, and we have a track view for the closer ones, but still unreachable. That's basically, they are basically pre-recorded and playing something like a cutscene. If you hit them, they will switch and play a death animation and die. And sometimes they will switch naturally to the correct NPC, and they might get close to interact. So player is now the battlements. This NPC now switches to the full simulation, and he can be fought. For the animals, I mean mainly wildlife, we actually don't use the LODs as well, because they don't have any identity. If you hurt an animal, it runs away, it won't remember anything. We don't use them in the global quest logic. They don't have to be referenced, they don't have to be there. So it would be actually completely unnecessary to simulate them. So that's why we are normally spawning them when player gets close. That actually halves the NPC number in our game, approximately. Okay, so the conclusion. It actually is possible to simulate the whole world. It could improve the immersion a lot. You can have way more detailed behaviors of the NPCs and better reactions. But if you want to do it, be prepared that it's a lot of work. If you want to do it, the good place to start is knowing the NPC position and if you want to know the NPC position, you probably need to know the NPC behavior and the constraints, but that's the very basic. If you can use threads, it probably won't be easy, but today computers have a lot of threads, so it would be waste to run everything on a main thread. A huge thing we did was we found a standardized logic in script, and we moved it to the code, which helped not only by speeding up the simulation, but the code also had way more knowledge about what is happening in the game and could do some other optimizations. And last but not least, it's important to set early limits for the systems and environment, like we did with the city. I know this is easier said than done, but when I was talking actually that for the first game, we first did all the features and then we optimized, I was making a little bit fun of that, but it's actually not a bad way to do a game. The important thing is that you have to have a plan what you will do in the future with the optimizations. So we actually, even for the second game, we actually did all the features and then implemented this LOD system. But we, from the very beginning of the development, knew this system will be there and what are the limitations. So a good analogy would be if you are borrowing a lot of money, you have to have a plan how you are going to pay them back. This is actually our 10 years worth of work almost. So I couldn't write all the people there. If you want to see all the people that worked on this, play the game, run the credits, they are there. But just the ones that did most of the work on these very things I was talking about, some people from the code and some people from the script. And that's actually it. So feel free to ask any questions here on or during the rest of the event, or you can even shoot me an email.